Okay, in this section we're going to talk about inverse functions, specifically inverse trig functions and inverse exponential functions, which we call logarithmic functions. But let's see when we have inverse functions first. So to have an inverse function, well, I need to be able to undo something. And to be able to undo something, I need to know that when I tell you where the function took you, you're able to tell me which input I used to get there. So we want to say that if I start in different places, I end up at different spots, right? So if if x equals y, if they are different input values, then f of x is not equal to f of y. So different input values give me different outputs. That means that if I have the same output, f of x equals f of y, right? If I tell you that the function gave me 4 when I put in x, and I also got 4 when I put in y, I want to be able to say that x was equal to y, right? Then x equals y. And these two statements are exactly the same logically. And if either of these happens, then the function f is called injective, which is the proper term, but most of you probably know this as 1-to-1. Right? It's a 1-to-1 function. Okay, and 1-to-1 functions have inverses because I can tell you if you give me the output what the input was, right? There's no confusion about which input you used. For example, x squared, this is not 1-to-1, since if I tell you the output was 4, we don't know if the input was 2 or if it was -2. So how does that work with these statements up here, right? So it says that if x is not equal to y, so if 2 is not equal to -2, those are true statements, that's a true statement, right? Then 2 squared does not equal -2 squared. And that's a false statement. So this one breaks because 2 is not equal to -2, but 4 is equal to 4, so that's false there. So x squared is a not 1-to-1 function. And we could see it here, like 4 equals 4, but 2 does not equal -2, right? That's that statement. Okay, so this is an example of a not 1-to-1 function. A lot of functions are 1-to-1, and we have a horizontal line test to test if a function's 1-to-1 by looking at the graph. Otherwise, you kind of have to go through the algebra up here and prove some statements about, well, if the inputs were different, then the outputs were different, or prove a statement about if I have the same output, then I must have had the same input. Okay. So that's what 1-to-1 functions are. The inverse function of a 1-to-1 function we usually write down as f inverse of, I'm going to put in y because I always think of my outputs as y and my inputs as x, and I'm going to put this as x. So inverse functions, they do the opposite of the function, right? So this is the same statement as f of x equals y, right? So my input x here gives me an output of y. Then the output of y inside of the inverse function gives me an input of x that would have got me there, right? It kind of flips everything around, right? It takes the original function's type for the output and makes it the input in the inverse function, and it takes the original function's input type and makes it the output type in the inverse function. So let me show you what I mean with like a trig function. So let's take y equals the sine of x. Usually this input type, this is an angle, and we usually like it in radians, right? And if I put an angle into the sine function, what do I get out? I get a ratio of side lengths. Right? Okay, so I've got an angle in radians as my input and a ratio of side lengths as my output. Well, the inverse function, which I can write as sine inverse of y equals x, or we have another name for this, which I like better because this notation almost makes it look like you're taking a reciprocal. We're not taking a reciprocal. I mean, it's a standard notation, but when we can avoid confusion, we like to. So this is the same thing as arc sine of y equals x. The inverse sine and the arc sine are the same function. It's just it's a different name for it. Okay. And so these are going to take ratio values, right? Y is a ratio, and the output is going to be an angle. So I'm going to give a ratio to this inverse function, and it's going to tell me which angle I could have put into the sine function to give me that ratio. So again, this is the ratio, and this is the angle. So let's see just a quick example. Arc sine of 1. Right. I want to know which angle would give me the arc sine, or sorry, which angle would give me a ratio of 1 if I put it into the sine function. And so if I think about that a little bit, I need the opposite side. The sine function is like in the SOHCAHTOA, sine is opposite over hypotenuse. So I need the opposite side and the hypotenuse to be identically equal. Well, I don't actually have a triangle there, so I'm going to be thinking about one of the points that's on the axis, and the sine, right? The sine is the vertical side, it's the opposite side of the angle. So when I'm going around the unit circle, I get up here. My opposite side is the vertical side. The hypotenuse is also the vertical side. So this is going to be at pi over 2. Right? Okay. What about the arc sine of the square root of 2 over 2? Right? Which is also the arc sine of 1 over the square root of 2. Well, I've got the angle here, which has the vertical side and the 45, 45, 90 triangle, right? As 1 over the square root of 2, and then the hypotenuse is 1. So I could have a pi over 4. But this angle over here also, this 45, 45, 90 triangle, also has an opposite side that is 1 over the square root of 2 and a hypotenuse that's 1. So the sine function, right, if I look at my graph of my sine function, the horizontal line test does not get passed. It actually fails miserably, right? Like any horizontal line in here crosses it infinitely many times. So when we were talking about viewing windows before, same sort of thing. I'm going to restrict where I use my inputs so that the restricted function, right, no longer using the natural domain, I use this restricted domain so that the function in this window is 1 to 1. The sine function, I'm going to start at negative pi over 2, and I'm going to end at pi over 2. And if I use that interval, the sine function would be 1 to 1 on that interval, right? Any horizontal line that crosses through this blue box, inside that blue box, that horizontal line crosses the sine function at most one time. And that's the number that we're going to pick out to be the arc sine, the inverse sine of whatever the ratio here is between 0 and 1, or between negative 1 and 1. Okay. So the one that I want to pick, this one, this angle here, this would be 3 pi over 4. Right? That's bigger than pi over 2. So it's not in this blue box, so we're not going to use this one, we're going to use this one. So this is going to be pi over 4. Right. So in your book, you're going to find the domains and the ranges for these inverse trig functions. But how that works is you're going to find on the graph a window where the function is 1 to 1, and that window is what tells you which outputs you can get from these inverse trig functions. Okay. Since we've talked about inverse functions a little bit here, now let's move on in the next video, and we're going to talk about logarithms and some logarithmic rules, because I want to spend a little bit more time and maybe a full video on logarithms and inverse logarithm log rules.